Hello and welcome to the Day 7 lecture for Upward Bound Integrated Math 1. Today we're actually going to start talking about linear equations and more specifically graphing those linear equations. So how to graph a line on the XY coordinate plane. And we're going to start that concept with talking about what slope is. Uh, and so the main idea here is that slope, get a little bit smaller, I guess. So slope is the degree of rising or falling of a line. Okay, so like we're looking at to what extent or to what severity is the steepness of the line. Maybe we can write that with it. Also, the steepness of the line. So we're not only looking at eventually we're going to look at where a line really exists, but a key concept to that is, you know, is it going upwards, is it going downwards, and in that, how steep of a line is that? The slope can tell us not only is it going upwards or downwards, but again also the severity of the, and for lack of a better word, the slope of a line. So I always think of a slope as like downhill skiing. You know, you hit the slopes. So that's kind of what we're looking at here is, you know, am I riding the bunny hills, or am I riding the really steep one? And, you know, do I have to go up the mountain, or am I coming down the mountain? So the key concept, and this is from a textbook. I just screenshotted it out of a textbook, and it just says that the slope m of a non-vertical line is the ratio of the vertical change, the rise, to the horizontal change, the run. And so what we use for that are very commonly used formula. We let m be the slope. I don't know why they chose the letter m, but they did, and so we've just kind of kept with that. And we're going to talk about the slope as it relates to 2 points. So given 2 points as x1, y1, because in order to talk about a location on a graph, you need an x and a y coordinate. So x1, y1, and x2, y2. We can talk about the steepness of the line by looking at the change in y, which is y2 minus y1. And it doesn't matter which ones are your 1s and 2s, but it matters that the order remains the same. So if I've started with this y on the top, on the bottom I have to start with this x. So then the way we denote that is x2 minus x1. And more commonly, it is considered to be the rise over the run. Okay, and rise is almost a bad word for this. It could also be fall. Like how far down does it go? It doesn't always have to be rising up. It could be falling down. Okay. The way I envision this and the way I try to find the slope of a line is I want to pick 2 points. So let me write out some steps here. So we pick 2 points, and we'll illustrate that with this one right here. Now when I'm talking about 2 points, I want to pick 2 points that are actually crossings. Okay. So, you know, kind of looking at here, this doesn't really cross at a true grid point, so I don't know the coordinates. This one looks really close, but I think it's just below this this -2 mark on the y in the y value here. So I'm not going to pick that one either. I think probably our best bet is going to be right here. So here is 1 point, and now I've picked that point. And I can go as far away or as close as I want to. I'm going to go quite a ways away from it and try to find another one. And it looks like, so if I start looking at this side, that's not a grid point, that's not a grid point, that's really close, but it's not. That's definitely not a grid point. I'm thinking this one is probably my best bet. So again, I'm trying to look at where this solid black line crosses at a true crossing of these lighter gray lines. Okay. And then, so that's step one. Kind of a more basic idea. If you want to kind of draw this triangle here, if you look at what they have done, this is called a slope triangle. That's one way you can do it. So maybe we say step 2 is to draw the slope triangle. Let's put that in quotes. So draw the slope triangle, and to do that, I'll take a different color. And I'm always going to start left to right. Let me reiterate that. From the left point to the right point. So however it works out, I'm starting as far left as I can, the farthest left point. And I'm going to draw a slope triangle here as good as I can. So it's going to go right up here and right over this way. So I've done as good as I could. You can draw over the line part if you want to. It's not required though. But this is my slope triangle, and I'm going to use that to calculate my slope. I'm going to figure out the rise, or how far it goes up or down. And I'm always going to denote that up for positive, down for negative. And so I'm counting 1, 2, 3, 4, 5. So it goes up 5, and we call that 5. You could say positive 5 if you want to. But I just know that it's going up 5. If it were going down, again, I would call that a negative. And then, let's see, for the run, we have 1, 2, 3, 4, 5, 6, 7, 8, 9. So if I start at my left point down here, I will always be going right. And that's kind of the point that I want to reassure us of. I always want to be going to the right. So that's why I started from my left point here. That was actually a pretty big deal. So in my steps here, I'm going to identify the rise and the run. Just to give a few pointers here, if the rise is upwards, it's positive. If the rise is downwards, we'll say that that's negative. All right. And I'm actually going to make this move it up a little bit and make it a little bit smaller, so that we can still read it, but it's also, I'm going to have to add a little bit more to it. So I've denoted my rise and my run, and then kind of our last step here, step 4, calculate slope as rise over run. And that'll be the last thing we do. So to write down the slope of this, I have my rise is 5, my run is 9. So I say m, or my slope, is equal to 5 over 9. And that's that. Okay. For the next one, let's try to do the same thing. I'm going to pick 2 points. So I'm going to start somewhere on the left, and I'm going to end somewhere on the right, and I'm just going to pick 2 points. Let's pick that one. Looks like a true grid point, even though I'm not too happy with the dot that I made on there. But it does look like a true grid point. And we'll pick one, let's say right here. This one looks good too. So I've picked my 2 points. I want to draw my slope triangle, starting from the left, going to the right. And then I want to identify my rise and run. So let's see, I notice that right now I'm going downwards. So that's going to give me a negative rise, or you might say a fall. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So we say it goes down 9, and we make that a negative. Then counting to the right, 1, 2, 3, 4, 5, 6, 7, 8, 9. So that's also a 9. So after I've drawn my slope triangle and I've identified my rise and my run, all I have to do is calculate my slope as the slope equals the rise. In this case, that's negative over the run. And so I have negative 9 over 9, which actually simplifies to give me negative 1. And that would also make sense. If I pick 2 points closer, I could see that this is a true grid point and this is a true grid point. And I could have drawn my slope triangle just right here. I've drawn them bigger to just kind of prove the concept and use it at any level. But you could have done it right here where it goes down 1 and right 1. Okay. And then also notice that a slope of a negative 1, and for that matter a slope of positive 1, doesn't give us like a horizontal or a vertical line like we might think. It actually gives us a kind of 45-degree angle line. It gives us a pretty good slope. I mean, this one is a lot flatter than this one, and we'll talk about that in just a second. So this next little snippet from a book kind of talks about that same idea. It talks about the 4 different kinds of slope, and I'm going to illustrate that with a little idea. Let's just take a look at these. So I've got my little buddy Spike here, and he's got spiky hair, so we call him Spike. And Spike wants to try to walk on these lines. Okay? And the way that I think about slope is the amount of work that he has to do to move from left to right on the line. So if Spike wants to take this first one and walk along this line, he's having to work really hard because he's having to work uphill. You know, it's like an incline on the treadmill. So he's working really hard to walk up here, and that hard work indicates a positive force that he has to apply to walk up this hill. So we call that a positive slope. Okay, he's walking uphill, he's working really hard. That's a positive slope. If he's on this one here, he's walking downhill. And that doesn't take as much effort as it does to walk uphill. So that's not a positive slope, that's a negative slope. Okay? You think about gravity kind of helping him walk down the hill, and it's a lot easier. If a Spike is on this line, he's walking straight across. Okay, that takes no effort in relation to what kind of hill there is. He doesn't get help by gravity to walk it, but he's just walking straight across. So that is a 0 slope. Okay, that is a 0 slope. And then if Spike tries to walk on this line, well, he just can't do it. He's just going to fall straight down. Okay, so that idea of falling or not being able to walk the line, we call that an undefined slope. So always think of spike when you're trying to see what kind of slope you have. And on this one, we think about the same thing. If Spike wants to walk along this line, he's working, he's having to work and walk up that line. So that's a positive slope. This one over here, gravity is helping him, so he doesn't have to work as hard. So that's a negative slope. He's walking downhill. Okay, and then the other two types as well. So I always think about spike when I think about walking a line and what kind of slope do I have. Now the other way to find slope, and when we found it up here, we had a line. Okay, we were looking at the line, we could pick 2 points, and we could look at our rise over our run. The other way to do it is what we talked about earlier with our equation of slope. So if we are given 2 points, I'm just going to move this down here because this is where we're actually using it. If we're given our 2 points, we can plug in the coordinates of those points and figure out our slope without ever looking at a graph. In order to do that, I'm always going to start off, if I'm given 2 points, naming one of these points my x1, y1, and the other one my x2, y2. So I'm going to go through and say this is x1, this is y1. Remember, x always comes first in an ordered pair. And then this will be my x2, y2. And now it's just plug and play into this formula. Okay, so I'm going to think about this formula, and I'm going to put the pieces in where they have to go. So for my y2, I have that assigned to 3. So this is going to be equal to 3. My y1 I have assigned to 5. So 3 minus 5. For my x2, I have that as a 2. Minus my x1 is 4. 3 minus 5 is negative 2. And 2 minus 4 is negative 2. Negative 2 divided by negative 2 is a positive 1. So my slope is a positive 1. It would kind of look like this line, but going in the positive direction from left to right. Go ahead and pause the video and try the next problem. I'll do the third problem with you. If you want to try it, you can, but pause the video right now, please. Okay, hopefully you had a chance to get that done. Label your x1s, y1s, x2s, y2s. So I labeled my points just the same way. You could switch them up if you wanted to, but know that the 1s have to go with the 1s and the 2s have to go with the 2s. So I could have said that this one was x2, y2, and this one was x1, y1. I could have. I didn't. I just went with the normal breakdown of it. And so what I'm looking at here is when I labeled it the way I did, not the way that I just talked about, but when I labeled it the way I did, I went ahead and plugged in the numbers where they go. And in doing that, I get 2 minus 5 over 5 minus 1. 2 minus 5 is negative 3. 5 minus 1 is 4. So negative 3 over 4 is my slope. So again, this is a negative slope. It will fall from left to right instead of rise. For the last one, same idea. I want to think about my slope formula. That's what this is. I want to label my 1s and 2s, or my x's and y's, whichever way you want to think of it. Actually, this time I am going to switch them. So let's look at what happens if I switch them. I'm going to start with my 2s, just to show you that it does work and there's really no difference. Okay. For my y's, y2 minus y1, y2 is 3, minus y1 is 0. x2 is 2. Minus x1 is negative 3. So I have to think about subtracting a negative 3. Okay, and just do the math there. 3 minus 0 is 3. And 2 minus a negative 3, minus a negative turns into add a positive. 2 plus 3 is 5. So I get a slope of 3 over 5, a positive slope, and that's about how it looks. Okay. If you want to look at where you get these other two types of slope, the zero slope and the undefined slope, for zero slope, you'll have something like m equals 0 over a number, let's just say 2, for instance, but this could be any number, but you'll have 0 on top, and 0 divided by anything is 0. There's nothing wrong with that. It's just you get a 0 slope. For one like this, you get something kind of the other way around, where you have any number on top. Again, just for sake of this argument, we'll say 2. But you end up with a 0 on the bottom, and we can't divide by 0. So we don't have a number for this. We just call this an undefined slope. Okay? Now moving on, we're going to talk about how to actually put this together with the rest of the equation and graph the equation. So what we're looking at here is the slope-intercept form of a line. And a line is written in slope-intercept form if it's written as y equals mx plus b. Now what that gives us, the m is, again, like we already said, the slope. So m is the slope, b is the y-intercept, so we're going to abbreviate that as y-int. So b is the y-intercept, and then x and y are going to stay in there as variables. So unlike solving equations, we have two variables, and they'll both be in our equation. So x and y are variables. Okay. M is our slope, b is our y-intercept. Those are the two important pieces of information. Okay. If we're to look at how to use it, we want to, again, I'm going to write out a set of steps that we can follow in order to complete this. Step 1, I'm going to say to plot your y-intercept. Okay. Whatever your y-intercept is, whatever your plus b is, you want to plot that on the graph. So looking at how to do that in this general form, I'm just going to say that my y-intercept is right here. I'm going to say that this is the b value, and I'm going to put a point here. Okay. So plot your y-intercept. Next, I want to plot another point using slope. Okay, and that's kind of a tricky idea, but using my slope, I want to kind of undo the slope triangle idea. And let's say that my slope is, I don't know, let's say my slope is, for general terms, c over d, because I don't have c and d labeled here. I'll go up c. Now let me use a different color here. Go back to green. I'm going to go up c and over d. And I'm going to plot another point at that spot. And realistically, it only takes 2 points to give a line. So step 3 could just be graph the line. I'll talk about how to make that a little bit easier as we get going here on some actual examples when it can be done. Okay. Sadly, I've started with kind of a tough problem, but that's okay. Just tough based on our graph. But after I've plotted my couple points there, I can go ahead and then graph the line between the 2 points. Rulers make this a little bit easier. Straight line tools on computers also do. But I want the graph to go, I don't really like this. I want the graph to go actually through, I want the line to go through the graph. I don't want, here's what I don't want, and I see this all the time. I see students plot their 2 points, and they just draw the line that connects those 2 points and say, there's my line, there it is, okay? Go through the added effort to draw it as straight as you can, as good as you can, and all the way through, through the graph here. So do your best. Try to make it, like I said, as straight as you can. You can use the edge of a paper if you have to, but do something to make it look like a good line. On this one here, we're going to try to graph this using slope-intercept form. So the first thing I do is plot my y-intercept. My y-intercept is 7. Again, we abbreviate that with y-int. So I'm going to 7. So this is, by the scale of this graph, this is 2, 4, 6, and 8's there, so it's going to be right in the middle. Then I'm going to graph another point using my slope. Now this is where it gets a little bit tricky. The number 5 for slope is always a fraction because we always have to go up and over. So this one, my slope is 5 over 1. So I would go up 5, 1, 2, 3, 4, 5, and over 1. Well, 1 is halfway in between these two, and 5, I mean, that just puts me off my graph. It's somewhere up here. I don't know exactly where it is. But I can follow that same idea and go the opposite direction. Instead of going up 5 and over 1, because that takes me off my graph, I can do the opposite and go down 5, 1, 2, 3, 4, 5, and over 1. And that's right halfway between these two. And that's going to give me another point right there. Okay, so in this case I've gone down 5 and left 1 instead of going up 5 and right 1, but it does give me the same idea. And let's see what it looks like with a little bit straighter line. So again, I want to draw my graph through, I messed that up again, draw my line through my graph, and it doesn't have to go like a long ways through my graph, but at least through the majority of my graph. And it doesn't have to be exact, it doesn't have to be exactly straight, but I want you to try your best. I expect at least this level of straightness and through my graph. This is the one I did by hand. I obviously used a straight line tool to do that one, so a little bit of cheating, but that's okay. Let's look at a couple more examples and then we'll call it quits for today. In this first one, my y-intercept is 3, but it's actually -3 because of this minus sign. So I kind of look at this whole thing here as my y-intercept. So my y-intercept is -3. And for this one, I know that it's m times x, but what number is being multiplied by x? Well, it's a 1. There's a 1 in front of that x. And then remember, I always said that slope is a fraction. So what is the number 1 as a fraction? Well, it's 1 over 1. Any whole number, you can just put a 1 on the bottom, and you're good to go. So the slope of this is going to go up 1 over 1. I kind of use the way we read fractions kind of informally to help me figure out what my slope is. We always say fractions like this is 1 over 2. This one is 1 over 1. And in this case, it's a positive 1, so I'm going up 1 over 1. Now here's kind of a pro tip on graphing. It's actually pretty hard to draw a straight line that goes through these 2 points and kind of continues on the same path. So what you can continue to do if you have space on your graph is you can keep doing that same up 1 over 1 all the way along your graph if you want to get a better idea of how to draw the straight line. There's no doubt that it's easier to draw a straight line given more points. Okay, if you have more points on your graph, it's easier to draw that as a straight line because you're covering more of the graph with points. And I'm doing just a great job at a straight line, but this is what I expect from you, okay? To go as far as you can, okay, in a straight manner. I kind of veered off course here, but I'm using a mouse. I could probably do better with a pencil and a piece of paper, okay? So give it your best, do your best. I don't expect perfection, but I do expect a couple things. Again, not just, you think about what this would look like for a student that just drew it in between the 2 points. If they just used these 2 points here that they originally found, their line would look like this. They draw that and say, well, it goes that way, and this is all they draw, right in between here. Okay, that's not a good representation of where this line goes. Eventually, we're going to get to a point where we want to extend these and maybe have multiple lines on the same graph and see where they cross. Well, that's really hard to do if I've only drawn right here. Okay. Last one we'll look at today. My y-intercept is, I always think about the sign and the number. In this case, it's +5. And my slope is the whole thing that's being multiplied by x. So in this case, it's -1 over 2. Now, it's not written the same way as we did when we found slope, but you could see this as -1 over 2. Okay, even though the negative is out in front, you can just as easily consider that to be part of the numerator for a fraction. So that means it goes -1 or down 1 over 2. Whenever I'm going over, I always want to go right. Okay, if I'm not told that I'm going in the opposite direction, I had to go in the opposite direction on this first one, but I'm going down 1 over or to the right 2. So let me again switch colors. Down 1 over 2. That would give me my next point. And again, I can continue that if I wish to get a better idea of where this line goes. And I can do it one more time. Okay, then I can follow that same trend if I have to. If I run out of room way too early, I can go the opposite direction. So just think of what these stair steps are doing. I can do that same thing in the opposite direction to get another point there. But it gives me a line that goes right through here. And that would be considered a pretty good graph in my book. Okay, it goes, the line goes through the graph. It's pretty straight. There's some bumpage, but that's okay. Just, again, do the best you can with the tools that you have. All right, and that's it for today. Stay tuned for the application walkthrough on this section, but make sure you get this done, get your mastery challenges done, and we will see you in class.